All right, here we are. 3 people in the chat. And I should probably mute my phone, just leaving that one here so I can see what y'all are putting in the chat. Cool, so yeah, the very first of its kind, Lambda Island office hours. Let's see how this goes. So, okay, I put a call out there. Yeah, don't mind what's on my screen right now. Okay, here we are. So I put a call out for people to send in questions, in particular if they had any questions regarding Lambda Island episodes or Lambda Island open source projects. That could possibly be Kaocha or Lambda Island URI or Deep Diff or anything like that. So we put that in the mailing list, we put that out on the blog, and eventually one person sent in an email with a question. And it wasn't exactly the kind of question I expected, but it's definitely a good question. So, okay, this is Johan. And Johan sent me this email. He said, "Hi, first I want to thank you for doing this. I will be watching as I really enjoy your other content. My question is, how would you handle doing a succession of logic, logic, etc.? Hope this isn't too vague. Thank you." Now, this is fairly vague. I mean, it's a really good question, but it's like, it really depends on the specific case. There's a lot of ways to answer that question, and maybe there's not even a good way to answer the question. No, so I poked Johan to get a little bit more details. And so then in a follow-up email, he said, so let's say you fetch some data online, that's I/O, and then you process it, that's pure logic, and then hydrate the data with more fetching, and then more processing, and then saving to a DB. Hi, Davide, at least someone in the chat already. How do you orchestrate this dance to keep the thing pure as possible and testable? I understand that to make I/O, you need to describe the action, and then some other piece of code will do the actions, but I struggle to see how to design such a system. Okay, so this makes it a little bit more clear where Johan's coming from, and I think this is a fairly common sentiment that people are, they're coming into functional programming, they're learning Clojure, they learn about pure functions, they want to write pure and testable code, and then they run into situations that just aren't pure, that inherently are side effectful. And they kind of feel like that's wrong, and they need to sort of have, figure out a way to do it the functional programming way. Now, let's unpack that, and I've tried to. I mean, it's a little contrived, but I hope it's somewhat. You can imagine this being somewhat a real life example. So, okay, say I have here a request handler, a web request handler. This thing is handling web requests, and in particular, this is a request where a user can request a report. So based on you imagine a service which has, I don't know, accounting data or analytics from whatever, and a user logs into there and they say, okay, I want the report for Q2 of 2019. So this is gonna just destructure some parameters that are coming in, and then it's gonna call some external service, maybe a database, maybe a web service, to get that report data. So I put a bag here to show that that's side effectful. And then it's going to filter that data, assuming that service doesn't do that yet. We kind of filter it on our end. We say, okay, we just kind of take everything out, only keep the stuff that's from the right corner. And then we have another service which generates a PDF, stores it in a CDN somewhere, and then gives us a URL back so that we can, redirect the user to that URL. And so this is what that response might look like, right? Okay, so Johan, this is how you do it. no, that's of course not the answer, although actually in a way it is the answer. So you start with the simplest things that might possibly work, right? And so here I've just sort of, made a single function that called these separate steps in order, and I end up with a result, and that might be fine depending on your situation. That might be fine, but let's think about all the reasons why that might not be fine. Okay, Johan has actually brought up one interesting point, which is testing. And why is this hard to test? Because of lack of isolation. You have all these services that you're calling in your tests, and so because it's not isolated, you lack reproducibility. Or to put this in another way, this test is not deterministic. So these are kind of things that are not nice in tests. You like tests that are deterministic, so that they always return the same result and that your CI doesn't fail for some random reason. So that's already an interesting thing to look at. But really, there's much more going on here. So the thing is that we are modeling something as a simple function, which takes some data and returns some data. But really what's going on is inside that function there's a whole process that's going on. And the thing is, every single one of those steps might go wrong. So, how do we deal with errors? And we're calling external services. We're gonna need timeouts on those things. How do we deal with timeouts? How about what was I gonna say? Consistency, right? I mean, in this case, we're only fetching data. But what if you're, getting data from some places and then updating data in other places? Intermediate results. What if this thing, again, maybe this is, well, the generate report PDF is something that would update something on the other side. But so, like, say you have multiple of these, what happens if your process fails halfway, right? And so the real issue here is that we're taking something that is inherently a process. It has multiple steps. It's kind of it's almost like a state machine. There's there's stuff that's going on. It's not instantaneous. It can fail halfway for various reasons, and we're treating it as a transaction. Or another way to put this would we're thinking of it as a function call. So programmers like to turn everything into a function call because that's sort of an abstraction that we know very well. But certain things don't fit very well into that mold. So okay, let's with that background, let's look at this code again, right? So, okay, a couple more people joined. So basically, the question we're answering is, how would you handle a succession of logic and I/O, so sort of a multi-step process that includes side effects, and in particular, how do you orchestrate this dance to keep things pure and testable? Okay, so let's have a first attempt. I'm actually, because this could be fun to look at later, so I'm gonna quickly snapshot this in Git. Cool. So, okay, ignoring all these other issues, a really annoying noise in the background. I don't know if that's just my laptop or what, or if it's part of the stream. I'll try to close the window. How's this? Is the sound better? Maybe it is your mic. Yeah, well, I mean, I do have one other option there, I suppose. Let's see if I can plug in this mic. I might have to restart the stream. That would be unfortunate. Okay, does this help? No. How about this? Okay, and you can still hear me? And the sound is better? Test, test, test. So I got this fancy as Mac, but I can't hear you now. Yeah, okay. Then that's not gonna work. Okay. Is this better? Can you hear me now? Can you hear me? Yeah, we'll have to do it with this, I guess. Okay, can you hear me like this? Can you hear me? Test, 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 test. Can you hear me? Test, 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 test. Test, 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 test. Test, test, test. Yeah, folks. Sorry about that. Test, 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 test. Okay, now there seems to be some audio coming through. I hope the noise is gone now, folks. This is the best I'm going to be able to do, I think. Okay. Sorry about that. Okay, so first question is really about testability, right? And for that, I mean, there's techniques that are really from object-oriented programming, but that are absolutely fine for something like this. So you could create a record, which is your report service. Actually, you would start with a protocol. And get report data would be a protocol function. And then you would have a record, real report service. which implements report service. So, okay, let's try that. So if we have that, okay, what am I doing wrong, folks? I think what I might be doing wrong is that I still have get report service as a regular function. Let me quickly restart my REPL. Right, and then here, you know, these functions that need that would take the report service as an extra argument, and we would just pass that on yeah, sorry about that. I'm still figuring out my streaming service or my streaming setup. There you go. Okay. Okay, so this works. And, you know, in testing, I would basically have a mock report service which just kind of returns some hard-coded data. So that's kind of approach one, right? And so this is a common thing, and especially if you use something like Stuart Sierra's component or integrant, it's fairly straightforward to sort of have a system, like a set of these things, and kind of wrap all your external access into these component protocols so that you can very easily swap those out, mock those out, kind of set those for hard-coded values. So that helps us with the testing. But that's not quite what Johan was hinting at. So he says, okay, I understand that to make I/O, you need to describe the action, and then some other piece of code will do actions, but I struggle to see how to design such a system. So this is a classic trick in functional programming to kind of separate your side effects from your proper code, from your functional code, by sort of coming up with a description of things. And so you kind of would have some sort of evented system where you have a description of the different steps that need to happen, and then some kind of engine that runs over that. Now, before I don't want to get into that too much just yet, But let's look at, okay, so we now have a way to isolate our test, but we still have these issues, right? Like, okay, what about errors? Okay, well, you could say, well, you know, if supposing that when these services fail, you get an exception, you know, okay, you can do exception handling the old-fashioned way. But still, right? Like you're gonna need timeouts around these things, and then you're gonna have separate paths. So then it starts in the end. It kind of turns into, you know, you're doing a try catch on every level, and then you might at every level have to distinguish between a regular exception and a timeout exception. Probably should swap these. Plus you want some retry logic, and before you know it, this thing gets really ugly and complex and hard to reason about. On top of that, you kind of lose the ability, well, you never really had the ability, like, say this goes wrong, you know, say you get an exception here. You don't really have your intermediate state. You kind of want to be able to see, like, okay, where in the process did things go wrong and what did I end up then? You know, maybe you want to, like, retry part of the process or restart or, you know, something like that. So this is where, this is the point where I want to talk a little bit about interceptors. So I did a video about interceptors for Lambda Island, episode 47, and it's a really neat pattern. It originated, I think, in Pedestal. It's also used by a Metosyn library. So originally it was implemented in Pedestal. I think then the next ones to sort of adopt it were Reframe, and then Siepari is a Metosyn library. Okay, that's interesting. Can try to figure that out. Okay, so yeah, don't know what to do about that. And so I did episode 47 of Lambda Island about interceptors, really talking about interceptors by themselves. So mostly interceptors are talked about in the context of handling web requests, handling HTTP requests. But I think it's a really neat pattern that's sort of underused for doing other stuff. And in particular at NextJournal, one of my main clients, we've used interceptors really extensively, especially to model these kind of processes. Now, in an interceptor-based system, you have your handlers all take a context. And when you handle, okay, so say I have my request, just kind of a ring request map. From params year 2018 quarter 3 user 1 to 3, right? Kind of same thing as before. And this goes into a context map. And then you enqueue interceptors. So in episode 47 of Lambda Island, I made kind of an academic implementation of interceptors, which is great for kind of better understanding interceptors. So I'm going to use that one. But it's conceptually exactly the same as, for instance, the pedestal interceptors. Okay, and now I'm going to implement request report as an interceptor. What's an interceptor? Well, it has a name. it has an enter function, and optionally it has a leave function and an error function. No, I'm not going to do anything with these yet. So I'm just going to put a response here to see if this kind of works. So I'm gonna enqueue request report. And then see if execute context. Does that work? Okay. That did not quite work. And Q takes a vector of interceptors. Yeah. So now our context has gotten a response. You can also look at the context kind of halfway before we actually execute it. So you see now it has a queue which contains a single interceptor which is going to execute. Now what I'm going to do is break up this process. So let me actually go back to our original implementation. So this has a request, and in the request there's form params, and in the form params there's a user. And so here I'm basically like, I would probably do some initial validation to see if this is a valid request, and then I would enqueue this fetch report data interceptor. And I have a leave function which builds up the response. Yeah, of course now I have the opposite problem probably. Oh no, okay, this works. Okay, so now our context contains the report data and the response. And then let's quickly do the other ones, and then I'll talk a little bit more about what this brought us. So this updates the report data filter report based on year and quarter. And then finally, oh, and this should not be as good as just the dash I for interceptor. And so this. Okay, so each of these are like little steps, little building blocks that all work on this context. They all take a context and return a context. And so here, I'm going to fetch the report data, filter it, and then generate the report PDF. And then finally, our response is going to contain a location header to that PDF. Status real. So you see, each of these only have enter steps. This one has both an enter and a leave step. And so you can think of this kind of as middleware in the ring context. Middleware also allows you to do stuff either before the actual processing or after the actual processing. And so here it's kind of similar, like so. This enter function is going to get called first. It's going to enqueue these extra interceptors. Then the interceptor chain is going to run these, so the enter steps of each of these. Then in the other direction, the leave steps of each of these, and finally the leave step of this one. So if we did that right, then we should be able to do this. And I guess we did not do that right because we used the wrong function here. I don't know, chat. This one. Ooh, interesting. I got an error, which is already interesting to look at because this shows us one of the things that these interceptors have bought us. So now this error has just bubbled to the top because we didn't handle it everywhere. I could have had a top level interceptor with an error key, error handler, which then can handle that. But so we have all our intermediate results here, which is great when you look at things as being a process rather than a transaction. By the way, if you want to look into this process versus transaction dichotomy, distinction, look up the talk by Avdi Grimm. I'll put it in the chat. So Avdi Grimm, actually I just showed it on the screen, I guess. Slider, sometimes you and me. So Avdi Grimm did two, I think, did a really good talk at Keep Ruby Weird. And since that talk, I saw that last year, almost a year ago, and since then I've thought a lot about the things he talked about, especially sort of process versus transaction, and how this is kind of a fallacy that a lot of programmers make. Now, what is the actual error that we have here? An arity exception in generate PDF. That just takes the data. Oh, 2 arguments positive associates because of course I did. Okay, and so now it works, and like your web stack, an interceptor based stack like Pedestal would then in the end pull out this response, and there you have your response, right? Now, why is this cool? Well, first of all, because now request report is purely functional, so we don't have to call execute here. Instead, we can just run this one step that has been enqueued, and now we see that we can inspect what request report has done to the context, and in this case it's just added more stuff to the queue. So that's something that we can test in a very functional way. And so you can test these individual building blocks. Now, what else have we bought ourselves? Less resource contention, and that's something that I didn't have in my list here yet. But if you think of the original version, so I just had this function like a web handler, which then went and did several separate HTTP calls. Now, imagine quite often you'll have your HTTP server like Jetty or HTTP Kit or something like that. They'll have a fixed thread pool that they'll use to handle requests. And so if you start doing these blocking things in your request handlers, then that's going to seriously impact how much traffic, even though at that point you're blocking. So like CPU wise, you're not doing much, you're just waiting for a response to come back, but you're hogging these threads that handle these requests, and so that's not great. Now with these interceptors, right, these are like in the individual building blocks that each just work, that each just take and return a context, and so you can imagine having sort of an internal thread pool that schedules one of these, executes it, and then does it all in async way. And in fact, both Siapari and Pedestal support this use case where you can, inside your interceptor, you can go async, and so I don't have core async I think on the class pad here, but if I would do something like this, so say I have a core async channel, maybe not here because this is somewhere where we are actually pure, but let's say where we're not pure. I could do this. I create a channel, and then I do this get report data. Now suppose this is actually using an asynchronous HTTP library, so we give it a callback. And then this one, is that right? No, it's the other way around, right? This one puts the new context onto that channel. And so Pedestal or Siepari will detect that now you've returned a channel. And so at that point it will go async, and it will basically, use a go block presumably to wait on the channel to return a new context and then continue the process. And so now that means that there's a lot less resource contention. So that's a great win. So yeah, this is really already more time than I really want to spend on this. But so interceptors, I think, are an underused pattern for this kind of stuff. Now, finally, and I'm not going to write that out, but I do want to say a few words about that. Like, if you really have a complex process like this, then maybe trying to model it as a function is completely the wrong way to go. And really what you want to look into is some kind of message-based system. So either something that kind of has, go loops that consume messages and do work that way. And then on the other side, you also asynchronously wait for a response. Because maybe generating this report, it can take a long time, it might fail. And so the user, you shouldn't just like try to do all of that inside a response. So maybe you should immediately respond with some kind of job ID. So there's many different ways to model this, and the real point is that there's no right answer, which is why this was a very hard question to answer. But you need to think about what your trade-offs, what your requirements are. To give one more example of the kind of thing you run into, like say you have timeouts and retries, and something goes wrong in the data center, which means certain requests start failing because say there's actually a server gets overloaded, so the responses get slower and slower and slower, and so you start timing out, even though the server was actually gonna answer you eventually. It was just busy with all the rest. But so you start timing out and you start retrying. So now you're even putting more load on that server. Plus, because you were doing this kind of stuff synchronously, now another service that is consuming you is also starting to get timeouts. And so this is the point where you might want to start looking into circuit breakers. Where you say like, okay, if a certain request fails a number of times, then we're going to stop making that call altogether, and then very slowly, a while later, check if it's okay again. So this is really dependent on the scale you're working on, the level of service that you want to offer. But I hope I've at least given people some ideas. That was part one I want to talk about, and we're already done 3/4 of my time for today. Maybe I can do a little bit longer. The other thing I wanted to talk about, I can't share this now very easily, or maybe I can. If I do this, where's my Firefox? All right, y'all can see that, right? I see this? Yes. So, okay, I've got a question on the Kaocha Slack channel. So someone asked, what is that greater than dash dash thing? The greater than bang bang thing is a core async thing. It means take. It means taking a value off a core async channel. So core async is kind of a big topic. And I've kind of assumed that people are familiar with the syntax. It's a little bit much to fully explain here. But basically it means, you know, you have an asynchronous channel, kind of like a queue. And so that function, I'm not sure if it's a function or a macro, I think it's a function, takes a single value of that queue. Okay, so I got a question here. Is it possible to specify binding values in Kaocha via the CLI? Now, I gave a bit of an example of how to do that with a plugin. But in the end, it turned out that this was kind of an what they call an A-B question. So a person is asking thing A, but really they're looking for thing B. And the thing B that they were looking for was essentially, I want to toggle some var when testing locally versus CI. And the cool thing here is that the configuration of Kaocha uses the IRO library. This is a library from Juxt. And that gives you a couple of reader macros that you can use in these configurations. So let me see if I can demonstrate some of that. Gonna switch back to Emacs and open my Kaocha. Yeah, so you actually, I mean, quickly go back. So this is what you were asking for, right? Actually, this is a put. So here I am putting something onto that channel. And then that channel, I should do it right here. That channel then gets returned from this function, and that's how the interceptor chain knows that I'm now going async. Okay, so Kaocha demo. Here's my test.eden, right? Okay, there's been a noise here because I've been testing some stuff out for Kaocha CLJS. Some improvements coming up there. But so the person was asking about this stuff. So this is a way that you can set dynamic bindings, which then will be set during your test run. And so here I'm using these, for instance, to switch on debugging so you get some extra output during the Kaocha CLJS. And so that person wanted, for instance, you know, to have false here in def, but to have true on CI. Now, what I typically do for this kind of stuff is I would make a, so normally this is called test.eden, but I would make a test ci.eden. And here I would include the other one, and then use merge. And I think it just takes, no, it must be like this. Bindings, Kaocha type, CLJS. Is that how it is? Kaocha type CLJS debug. True. And here, false. Why is that cool? Let me actually see if I can get a terminal here. Right, so this is a fully expanded config. Yeah, people have already complained about the sound, but I mean, I really can't fix this now inside this session. I'm really sorry about that. I have to figure that out some other time. So, actually, is this better? Sometimes it's just a matter of unplugging some cables. Or actually, it might also just be that I put my monitor on a different resolution to reduce the load on the CPU for the streaming software. Yeah, this is I haven't done a lot of these sessions yet, so this is all figuring stuff out. Okay, but what I wanted to show was, so this is our original configuration. It's fully expanded now. And you see here, this is the binding we set, which is false. Whereas I should be able to say pin Kaocha config test ci.eden. And then if all went well, if I did this right, it's config file. These externals. Config file test ci.eden. Yeah, so okay, this is actually, do have to watch out here a bit, so this already gets the expanded configuration, so we do need that. Yeah, because here you see the other value, but it hasn't actually, it should have overwritten this one. But if we do this again, yeah, and now it's done. So this is a really cool way if you want to have like different settings in CI versus locally, you can do this. I'm thinking of an even neater way. So IRO has this concept of profiles, and currently we don't really use that in Kaocha yet, but I think maybe in a future version we will do something like this where you can say, default false, CI true, and then we actually just kind of auto detect this CI environment variable, which all common CI providers set, and then we can set the profile accordingly. Now, his original question was, or my original suggestion was, to do this with a plugin. And let's maybe quickly look at what that would look like. So, say I have source, my Kaocha plugins .clj. So this is completely untested code actually. I'm kind of curious how it will already work. And then I'll get REPL going, it'll be a little bit easier than trying to continually run this on the command line. And then I'll go back to my tests Eden and add this here, my Kaocha plugins. CLI bindings. Okay, we have a REPL, and then REPL sessions. Test. Where's this coming from? Okay. Yeah, let's actually see if this namespace evaluates. That plugin comes from. I guess I do need that. Kaocha plugin require dev plugin. Dev plugin is a very simple macro. So what a Kaocha plugin really does is extend a multi-method. Plugin. Not require refer. So if I do a macro expand on this might be a little noisy. Let's see what that actually did. Okay, so it defined two functions. It then defines this var, which contains a map, and then it does a def method. Which just does a conch. Now these, you could roll this all into one, and that's what the original version of the macro did, and saying just kind of inline these functions here. The only reason this is now sort of split up, that it actually defines these functions and these vars, is for easier testing. So you can now you can easily write unit tests for a specific hook. But so a plugin is really just this. It's a multi-method implementation for the register method, and register contains what Kaocha calls a plugin chain. And the plugin chain is basically just a sequence which contains maps, and these maps contain hook implementations. So for instance, Kaocha hooks pre-run. the next one might implement Kaocha hooks wrapper. I don't know. And so this plugin adds itself to that chain. It also has an ID and optionally a description. Now dev plugin kind of makes it feel a little bit more like a dev record or something, where you're implementing these hooks kind of inside this syntactic form directly. Now, which hooks am I using here? I'm using a first hook, which is the one that Kaocha invokes. So Kaocha kind of runs in two steps. It first parses already some amount of command line arguments to find plugins, and then uses those to expand the total set of command line arguments that it understands. And then it parses the command line arguments again with this new set of command line arguments. And so this plugin adds an extra command line argument that's just binding. And so the idea is that, you can give that basically an hidden form, and it's going to use that for bindings. I was first thinking of doing it differently, but I think this makes much more sense. And actually, then we also don't need this accumulate. So this is this is kind of a DSL provided by what's it called? The closure tools. One of the closure tools, the one that does command line parsing. Okay, and for parsing, I'm just gonna say read string s. Okay, so this way you're gonna be able to say being Kaocha -- binding Kaocha types CLJS debug. True. That's kind of the idea. And so it first implements CLI options to just add this extra option to the existing list of options. And then it implements config, and at that point it'll find in the config sort of the parsed CLI options, and then it can pull that out and stick that into the config. So let's actually see if that works. Test. Okay, that looks legit. Because I have some this still in here. So I don't know how you get history in Nazi term. Oh, maybe if there you go. Just not really compatible with Spacemacs. Java-lang boolean cannot be cast to Java-lang string. Interesting. That sounds better. But so you can see also in the help, so that's kind of the cool thing, that so when these plugins add these extra command line arguments, they, you know, they're part of the whole same system, so you also see them in -- help. And here's our extra binding. So this way you kind of see that, like, okay, you know, like adding a -- binding flag could be a great feature for Kaocha, but, you know, in the meanwhile, like if you look at it, you know, really this could have just been read string. So like in a dozen lines, we've implemented this ourselves, and you just add this file to your project, put it on the class path, and you can start using that. And okay, I'm already running a little longer than I expected, but I want to show one more thing on the topic of plugins. A cool thing that you can do. So let's say I have an env filter, and basically what I want to be able to do is to let me open a test file here. Okay, say I have a test here. See, let's make this more concrete. Let's say that I want to be able to tag tests only on CI and tests that should not run on CI. Maybe you want to use namespace keywords, that's fine. So for this, I think you use a pre-test plugin. Let's see, what do we have? Yeah, a pre-test. Pre-test runs before every single individual test. And so let me find an example of a pre-test. Test, that's cool. Yeah, so it gets a testable and a test plan in that order. Yeah, and this is exactly actually the kind of thing we want to do. Before I use that, I'm gonna go back to my REPL namespace. So, and look at the test plan. So Kaocha works in two steps. You start with a config. The config gets loaded, turns into a test plan, and then the test plan gets executed. And so this test plan is a recursive data structure which reflects, you know, the structure of your tests. So here we have, at the top level, this is a test suite. Well, this is your test plan, which contains a Kaocha test plan tests, which are your test suites. So this is a sequence of test suites. Each test suite again has tests. Oh, and my Emacs is not happy with such a big file. So this test suite contains then tests for each namespace. So you see this is now a test corresponding with a ClojureScript namespace. And you see some metadata about that namespace. And then that namespace contains the individual tests. including metadata that was defined on that test var, or whatever level you're defining that test. It's if you define metadata on a namespace, then you'll see that here. So basically what we want to do here is first detect if we're on CI. So that's system get env CI is true. And then let's pull the test metadata out. And basically, if either we are on CI and what did I call it? Not on CI. Or we're not on CI and we want this only on CI, then add this Kaocha testable skip true, which is then going to cause Kaocha to skip over this test. So now, let's see if we say now I don't know. Yeah, the thing is, I configured my streaming software to like only show my Emacs, so if I switch to other windows, it doesn't show them. So that's why I'm trying to do everything in Emacs, but I don't really use this Emacs terminal a lot because it's a bit wonky. But that's fine. What do I actually have configured here to run CLGS tests on Node? Okay, that should be fine. What happens if you do Kaocha? Thank you all for watching. I'm really sorry about the audio. I'll do some more testing by the time we do this again. I think it might have to do with the resolution of my monitor now that it's a 4K monitor, but now it's running at 1080p. Just to sort of, because when I was streaming with Felipe yesterday, it was running at full 4K, and my poor laptop CPU was just going crazy. Yeah, we got a bit of debug output. It's just something to fix. Which test is this running? Demo tested. Okay, it's actually running these tests. Okay, and So for instance, let's see, term example without timeout, example with timeout. So let's say that this one is only on CI, this one is not on CI. And so you can do all kind of fun stuff with this, right? Like you can also, so Kaocha already contains built-in a plugin where you can do stuff like, I don't know the exact key I'm using, but like you can do something like this. And then, you know, if you run your test suite on Clojure 1.8, then that'll get skipped. So these are kind of things that you can do, and especially if you run your tests on many different environments, you know, there are certain tests that you only want to run when you're on Mac, and certain tests that you only want to run when you're on Linux, you know, these kind of things. Or and so that's all kind of things where I think this metadata approach is really great. Anyway, we were quickly testing our filter because I'm going to wrap it up then. So now we didn't set the CI variables, so I guess the first test should run, but the second one shouldn't. Thanks, Vincent. It's very nice of you. Hopefully I'll be able to get back to Taipei at some point to come and say hi. Okay, so now we ran the without timeout test. And now let's try this again. Clojure script always takes a little time to boot up, but it's running now. So now it ran the with timeout one, and before it ran the without timeout one. So that's correct. So that's awesome. Okay, I hope that was fun and interesting. The video will be online on YouTube. I got some pretty good noise cleaning plugins, so when I get the chance, I guess I'll download it, clean it up, and re-upload it. Yeah, hope to see you all around. Thanks for watching.